Here are solutions for quiz 6 for Math 251. First two problems are related rates. The first one, we're told that the volume of a square-based pyramid is given by this formula. Fine. H is the height, L is the length, V is the volume. And then they give you a bunch of information, and they ask you at what rate is the height of the pyramid growing. So the three things we have are, maybe I'll write it in the middle, length, width, no, that's not true, length, height, and volume. And maybe there'll be some mention of the change in those things. And generously, we were given the relationship between the length, the height, and the volume by this formula right here. So let's see what they give us. If the volume of the pyramid is growing at a rate of 20 something, in other words, volume change 20, V prime 20. And the length of a side of the base is growing at a rate of 3. In other words, length changing 3, L prime 3. At what rate is the height growing? H prime is what I'm going to be looking for. Doesn't really look like a question mark, but it is, I swear. When the length of the base is 2 and the volume is 4. Conspicuously absent is H. They don't give me H. So I have a couple options. I'm going to label them as option 1 and option 2. Option 1. Let's first find H. How can you figure out H? Well, I have this formula that relates together V, L, and H, and I have L and V. So I know that V, which is 4, is equal to L squared, which is 2 squared, times H divided by 6. Do some quick math and you'll figure out that H is equal to 6, I think. Let's see, multiply both sides by 6 and you'll get 24 equals 4H. Divide by 4, I'll get H equals 6. Or this is 4 and this is 4. Divide both sides by 4 and you get 1 equals H over 6. Whatever. H equals 6, however you want to figure it out. The first option is to first figure out that and then just take the derivative of both sides. Then take deriv. So I got if V equals, maybe instead of divided by 6, I'm going to think about it as 1/6 times L squared H. And V prime is equal to 1/6, which is just a constant, times the derivative of L squared H. Using the product rule, the derivative of L squared is 2LL prime. There's actually a chain rule in there as well, times H, plus the derivative of H is H prime times L squared. So I get all this information. I know all of the pieces, so I guess I could solve this for H prime and get my answer. Maybe I'll just write that here. Solve, plug in. And solve for H prime. That'll absolutely work, and you're perfectly fine doing it that way. Another option, just since I'm here, is since I didn't originally know H, I know I solved for it over here, but originally that wasn't given to me in the problem. If I solved this for H, then when I take the derivative of both sides, I won't have any H's in the problem. So I can multiply both sides by 6 and then divide by L squared to get that H is equal to 6V over L squared. And now if I take the derivative of both sides here, I'll get H prime equals, using the quotient rule, the derivative of 6V is 6V prime times L squared, minus the derivative of the bottom, which is 2L times L prime, times the top, which is 6V, and divide that entire thing by the bottom, L squared, squared. In other words, L to the 4th power. Let's see, I got an L here, an L here, and an L here. I could simplify this and make it 6V prime L minus, that L's gone, 2 times 6 is 12, 12, maybe VL prime, if I want to write the derivatives last, divided by L to the 3rd power. And plug everything in, you get H prime equals 6 times V prime, 20, times L, which is 2, minus 12 times V, which is 4, times L prime, which is 3, divided by L cubed. L is 2, 2 cubed is 8. I guess I could do that. Let's see. 40 times 6 is 240. 12 times 12 is 144. 240 minus 144 is 96, and 96 over 8 is 12. So your final answer is 12. This is option 2 over here. The difference between option 1 and option 2. So solve for h prime, maybe, and get h prime equals 12. Should get the same answer no matter how we do it. I'm not going to work this out because I trust that I did it right, or that somebody will catch it if I didn't. Get your answer here, then we're done. Moving on. Maybe I should move a little quicker so this video isn't 20 minutes long. If I am currently 8 miles north of school, here's school, here's me, I'm 8 miles north. Maybe we'll call this A. So this is school. That says school, I swear. And this is me. And you are 6 miles east of school. Let's see, east would be this way. Good enough. This is you. Maybe we'll call the distance from you to school B. And while we're here, let's call the distance from me to you, call that C. And then go through the problem and see what we were told. If I am currently 8 miles north of school, in other words, A is equal to 8, and running directly to school at a rate of 5 miles per hour. So be careful there. A is getting smaller. I'm running to school. A prime is not 5. It's negative 5. You are 6 miles east of school. So you, B, distance from school to you is 6. B prime, you're running away from school at a rate of 7. B prime is equal to positive 7 because B is getting larger as you run in this direction. Put this in bold to really emphasize that up here you're running away from school. I'm running to school for whatever reason. So this one negative, this one positive. Then the question goes on to ask, how fast is the distance between you and I currently changing? What's C prime equal to? Well, a couple different options on how you could do this. You could either say a squared plus b squared equals c squared. Maybe I'll write over here in a different color. Or you could say c is equal to the square root of a squared plus b squared. Either way, I don't care how you do it. I'm going to do it the red way. Why am I going to do it the red way? If you do it the red way, you're going to need to know what c is, right? If I take the derivative of both sides here, I'm going to have a c and a c prime. If I take the derivative of both sides here, I won't have a c. I'll just have a c prime. But c is pretty easy to figure out. Why is c easy to figure out? Because this is a 3, 4, 5 right triangle. This is twice 4. This is twice 3. So this must be twice 5. In other words, 10. Maybe I should explain that in case people aren't watching the video. 10 squared equals 6 squared plus 8 squared. Or 3, 4, 5 right triangle. Anyways, once you know c, you can take the derivative of both sides here, and it's pretty easy. 2a, a prime, plus 2b, b prime is equal to 2c, c prime. So if you solve that for c prime, you get that c prime is equal to a times a prime plus b times b prime divided by c. Probably done this so many times that you just remember that this is what it ends up looking like, or you solve it algebraically. Plug in all the numbers. A is equal to 8. A prime is equal to negative 5. B is equal to 6. B prime is equal to 7. And C is equal to 10. So I get negative 40 plus 42 divided by 10. In other words, I get 1/5. Miles per hour, whatever. I don't care about units. I'm fine with just 1/5. How fast, interesting, about how fast is the distance between you and I currently changing? It's changing at a rate of 1/5. It's getting larger. The distance between us is increasing at a rate of 1/5. All right, let's try this again. I'm going to change the problem so that the function you're given is 1/2 x squared minus 24 times the cube root of x squared. That function can be written as 1/2 x squared minus 24x raised up to the 2/3 power. Okay, now I'm going to redo all the things that I just did, although you won't see that I just did it because I'll cancel out that part of the video. I'm going to find these critical values. To find the critical values, maybe I'll write that, critical values. They come in two flavors, when f prime of x is undefined and when f prime of x equals 0. So sort of two different things I'll have to figure out for this problem. Either way, I'll have to know what f prime of x is. I got f of x, but I could figure out f prime of x. So the derivative of 1/2 x squared is just x. Bring the 2 down in front. 2 times 1/2 is just 1. 2 minus 1 is 1, so it's 1x to the 1 power, aka x. Minus 2/3 of 24 is 16. X to the 2/3 minus 1 is negative 1/3. This right here is our derivative. I got to figure out when this right here is undefined and when this right here equals 0. To figure out when it's undefined, let me rewrite it. Instead of x minus 16x to the negative 1/3 power, how about x minus 16 divided by x to the 1/3 power? This is undefined. I can't divide by 0. No issues with square roots or logs, but I can't divide by 0. I'd be dividing by 0 if x to the 1/3 power were equal to 0. Algebraically, you could cube both sides of the equation and get that x to the 1/3 power equals 0 when x equals 0. What I'm saying is if x equals 0, the cube root of 0 is 0. 16 divided by 0, undefined. Because the first derivative is undefined when x equals 0, it means x equals 0 is a critical value. What about f prime of x equals 0? Well, f prime of x is x minus 16x to the negative 1/3, which maybe I'll do the same thing I did over there. Let's write it as 16 divided by x to the 1/3 power. And I want to know when that equals 0. Let's take this mess and add it over to this side. X equals 16 divided by x to the 1/3 power. Let's get all the x's together on one side by multiplying both sides by x to the 1/3 to get x to the 4/3 is equal to 16. Really got to be a little bit careful when you multiply both sides of the equation by a variable. Can't be multiplying both sides of the equation by 0. Right? You'd lose all the information. We don't have to worry about that though, because when x equals 0, the first derivative is undefined. We've already taken care of that case over here. So we're not considering that case over here. X to the 4/3 power equals 16. Okay. To solve for x, I could cube both sides of the equation. I don't want to know what 16 cubed is. I mean, you could figure it out if you want. 5, I don't know what it is. 16 cubed, you could figure it out if you really felt like it. I don't feel like it. So instead of first cubing both sides of the equation, I'm instead going to first take the 4th root of both sides of the equation. The 4th root of x to the 4/3 is x to the 1/3. The 4th root of 16 is plus or minus 2. Now if I cube both sides of the equation, I get plus or minus 8. And so I get 3 critical values. When x equals 0 and when x equals plus or minus 8. All right, and for this second one, we're going to have the function g of x be equal to x squared times 2 raised up to the x power. Weird, but okay. And you're asked to find the critical values. To find the critical values, you're going to need to know the first derivative. We'll figure out the first derivative using the product rule. The product rule tells us that the derivative of f times g is f prime, 2 times x in this case, times g, which is 2 to the x power, plus g prime, which is 2 to the x power times the natural log of 2, times f, which is x squared. Get this mess right here. That's not gonna be fun to figure out when it equals 0, stuff like that. So I'm gonna clean it up a little bit. I'm gonna note that both of these terms have a 2 to the x in them. So I'm gonna factor out that 2 to the x. And what you'll have left is 2x from this term and natural log of 2 x squared from this term. And yeah, you could factor out more. You could factor out another x, but I'm not going to. I'm going to leave it like this, and I'll show you why in just a minute. So here's my first derivative, g prime of x. First, note g prime of x is kind of a double negative, never undefined. It's always defined. Why? Because this is just a polynomial, basically. I mean, because the things that are going to cause trouble is taking the natural log of, or taking the log of a number that's not positive. No problems there. I'm not taking the natural log of any variables. Dividing by 0 or taking the square root of a negative. None of those happen. However, g prime of x equals 0 could happen. Figure out to solve when g prime of x equals 0, let's take our derivative here and set it equal to 0. So I got 0 equals this thing times this thing. And I'm going to read, I don't want you thinking it's the natural log of 2x squared. I want you to know that it's x squared times the natural log of 2. So I'm going to write it in this order. Something times something. That can only happen if 2 to the x equals 0. This is all backwards. The only way this times this can equal 0 is if this thing's 0 or if this thing's 0. 2x plus x squared natural log of 2. This is never 0. No solutions. Why is that thing never 0? Because you're not going to raise 2 up to a power and make it equal to 0. 2 to any power is a positive number. It's never going to be equal to 0. Another reason, because if you were trying to solve it, you take the log base 2 of both sides of the equation. Log base 2 of 0 is undefined. X equals undefined. There's no solutions here. This one, however, does have solutions. Figure out these solutions. This equation has solutions. I'm going to factor out an x from both sides and get 2 plus x times the natural log of 2. So I got something times something equals 0. That happens if x equals 0, if this first thing equals 0, or if 2 plus x times the natural log of 2 equals 0. The second thing equals 0. So I have this solution right here, and I'm going to try to get another solution from this. To isolate the x, I'd subtract 2 from both sides. X times the natural log of 2 is equal to negative 2. So x is equal to negative 2 divided by the natural log of 2. These are my critical values, and that finally ends this video.